Hello and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some interesting work in the AI space. We'll be looking at a paper titled Docling Technical Report. So this paper introduces Docling, which is basically an easy-to-use open-source package designed for converting PDF documents. What's neat is that it uses specialized AI models for understanding document layout and table structures, and it's built to run efficiently even on regular computers. Plus, it's open source, which is always great to see. Right, and speaking of open source, this image actually shows the Docling GitHub repository page, so you can see it's publicly available under an MIT license. The repo itself, as the description says, is there to help you get your documents ready for generative AI. It contains all the Python code, documentation, and examples you'd need to start using Docling for processing various document formats like PDFs. Right, and this figure here actually sketches out the default processing pipeline for Docling. So you start with your input PDF document on the left. First, Docling parses the PDF pages to get the basic content. Then it enters this model pipeline stage. Here, it can optionally run OCR. Then it performs layout analysis and table structure recognition using those AI models we mentioned. After processing all the pages, it assembles the results, applies some post-processing, and finally spits out the structured information as JSON or Markdown. So after going through that whole pipeline, this table actually gives us some numbers on how fast Docling runs. It's showing the runtime characteristics on a test set of 225 pages, comparing different CPUs and two different PDF backends, native versus one called PyPDFIUM. It looks like the PyPDFIUM backend was generally faster and used less memory across the board in these tests. For instance, on the M3 Max chip, it finished in about 103 seconds versus 177 for the native backend using 4 threads. So yeah, performance depends on the setup, but it shows it can run reasonably efficiently. So we just looked at how fast Docling runs, but how well does it actually understand the document structure? Well, this figure gives us an idea of the prediction performance for the layout analysis part. It's based on the DocLayNet dataset, which is used for training these kinds of models. There's a table here, Table 2, that compares different AI models, like Mask RCNN and YOLO, against human performance at identifying things like captions, tables, and text blocks. It uses a metric called MAP to score them. And then there's also a graph which shows, it shows that the more training data the model sees from DocLayNet, the better it gets at prediction, although the improvement tends to flatten out after a certain point. It helps show the quality of the underlying AI doing the layout detection. Wrapping things up, we've seen Docling offers a pretty solid open-source way to tackle complex document analysis, from layout detection to extracting text. It seems like a valuable tool for researchers and developers needing to process diverse documents efficiently. Making this kind of advanced document AI more accessible is definitely important work in the field. Well, that's all for this week's AI Research Roundup. Thanks so much for tuning in. I'm Alex.